remind everybody of the final due dates coming up. The homework on linear programming is due tonight. So make sure you go and do that homework assignment. And after that homework assignment closes off for tonight, then sometime tomorrow I'll go through and drop the 2 lowest homework grades. So expect your grade to go up a little bit, especially if you have 2 incomplete or lower homework assignments. Expect your grade to go up a little bit. And then the corresponding quiz is due Thursday, so tomorrow. So make sure you do the quiz as well. And after the quiz closes on Thursday, I'll go in sometime Friday and drop the 2 lowest quizzes. So because there's less quizzes, expect your grade to go up a little bit more. And this is contingent upon if you have 2 low quiz grades that are bringing your quiz grade down a little bit. So homework tonight, quiz tomorrow. I'll be dropping the 2 lowest of each after they close. So I'll do that sometime the following day. And there's a practice test. We're going to be going over the practice test here in class today. I do also have a workbook assignment that's due here. It's technically 1 assignment broken up into 6 parts. This is a linear programming problem, and I think this would be a very good problem to make sure you do correctly, because I think this will best model a linear programming problem that you get on the final exam. So I think it's important that you make sure that you can do this problem in the workbook, because this will best resemble how you will see the problem when it shows up on the final exam. Of course, with the final exam, I'll talk about the final exam here in a bit, but you have scratch paper, and I grade your partial credit just like with the midterm. So all of that stuff works the same way. And with the linear programming stuff on the final, you can expect that it's going to be piece by piece, and I can grade and see where you went wrong and try to give you some partial credit for what you attempted. So make sure for this workbook 8, you pay attention and really make sure you do this one correctly. Besides for that, does anyone have any questions before I start talking about the exam, generalities regarding the final exam? So if not, I'll go ahead and just explain some of the bits of information about the final exam. So the final exam, you will have 75 minutes to take the final. It's not really a final exam. It's not completely cumulative. The final exam, according to the syllabus, is 1/3 of the material from the 3rd unit. The 3rd unit being everything on statistics and whatnot. So it's 1/3 of that material, and 2/3 of the material is based off of this newest unit. So 1/3 of the material is from everything regarding statistics. So these sections here, proportional reasoning, solving linear equations, measures of central tendency, dispersion, normal distributions. That'll be 1/3 of the test. And then the 2/3 of the test will be everything we learned after the 3rd assessment. Systems of linear equations, all the way up to the linear programming stuff we did. And again, 75 minutes to take the test. I cannot remember how many questions are on the test, but as I've sent out emails about, and you should have received the email as well about signing up for the final. Hopefully you have all done that by now. Of course, the final will take place in the tutoring lab, just like the midterm was. It'll work very similarly to the midterm, except of course you're going at a time that may be different than your classmates. Besides for that, there is an email about, I guess, the conduct in the lab or whatever, some email I have to send you all about what to bring, what not to bring, what to do when you go to the lab and all that. So I'll reserve all of that information for that email. I'll probably send it out on Sunday. But yeah, that's as far as generalities go. Again, 75 minutes, 1/3 from Unit 3 material, 2/3 from the Unit 4 material. and you'll have scratch paper to write all your scratch work down. I go through and I grade that. And additionally, I'll also, every semester I send out an email because I start getting a flood of emails regarding what grade do I need to make on the final to make this grade in the class. And so I've relegated that question to a formula that I send out that you can all just plug numbers into and you can figure it out on your own. Expect that email later today or tomorrow. But it'll pretty much just relegate what grade you need to make. You can figure it out for. Do you want a C to finish the class or a B in the class? What final exam grade you would need to make that happen? But other than that, I think that's everything I can think of as far as the final exam goes.
There's a practice test for it, like an intern?
Yeah, it's right here. And that's what we're going to be discussing today. We're going over that. So there's a practice test. Again, it's optional. You don't have to do it. You can if you want to, but it's not going to affect your grade one way or another. Did I miss anything? Does that sound pretty conclusive? That's all I could think of, though, for now. I'm going to assume that takes care of all the generalities, and I guess I'll just open up the practice exam unless anyone has any final questions. All right, let's go ahead and start the practice. Okay, so this is a problem where we graph a system of inequalities and identify each vertex, as they call it, which we'll talk about here momentarily. So they give us 4 different linear inequalities here. And you might actually notice that 2 of these are pretty simple to take care of. The ones I'm highlighting here are the non-negative restrictions. And with non-negative restrictions, we have a pretty straightforward way of taking care of those. So as I open up the graph here, so with the non-negative restrictions, as soon as I see them, that tells me just make sure there's solid lines on the X and the Y axes. And I just plotted 2 points anywheres, it doesn't matter. I just want solid lines on the X and the Y axes. And that's what I did so far. So notice there's 2 lines corresponding to each axis. So that takes care of those 2. And now this means we need to also take care of the other 2 lines. So the next line that we can look at, let's go ahead and save that. Now let's look at the other 2 lines. So get y is less than or equal to x, which that would be 1 line. Now, if we went through and tried to determine the graph of y is equal to x, if you try to find the x and the y intercept, you're going to get 0 for both of them. But you need 2 points in order to graph a line. However, we're already given mx plus b form, so we can actually plot this thing very easily. So normally we use x and y intercepts if an equation is written in a somewhat jumbled way. Most of the time we use the x and the y intercepts, but here we have that the slope is 1 and the y-intercept b is 0 because there's no plus b, there's no plus a number. There technically is, it's plus 0. And so with this tells us that for this line, we can start at the y-intercept, which is 0, so I'm plotting right dead in the center. And remember, with the slope, you go up 1 and over 1. So notice it's a perfect diagonal. That's y is equal to x. And we'll worry about the inequality once we plot all the lines. I'm going to exit out of that. Probably save first. Try that again. All right, there we go. So finally, there's one more line. X is less than or equal to 11. So that'll be the second line here. X is less than or equal to 11. But we need to go ahead and graph X is equal to 11, the underlying equality. Now, this is also tricky in the sense that if you try to plug in X is equal to 0 and Y is equal to 0, you're not really going to get any information from that other than X is equal to 11. So instead, you have to identify when X is equal to 11, well, the X-axis is the horizontal line, and 11 is right there. And you can see a little circle on the screen just popped up around 11 on the X-axis. Now, X is equal to 11, that's a special form. That's a form of a vertical line. So you just need to make sure that this vertical line occurs in any way, any 2 points to make a vertical line happen at 11. That's all we need. So this is the graph that we obtained. So this is a vertical line at X is equal to 11. So it's not just a random vertical line. This is a vertical line passing through 11 on the X-axis. So from here, we have, well, the non-negative restrictions tells us we're only allowed to deal with the this region up here. That's what the non-negative restrictions tell us. And furthermore, the lines that we've graphed tell us that we're only allowed to shade these 4 regions. Now the first line, this one was L1 and this one was L2. So we need to figure out which direction we shade in. So normally we use the point 0, 0. And these are, of course, all solid lines because they all have equal to components. So now for the first line, we want to go ahead and, well, if we try to test 0, 0, there's a problem for that diagonal line. And we did a problem like this in class. If we try to test 0, 0, we do get a true statement, but that doesn't necessarily tell us what side of the line to shade on, because the line passes right through the point we're trying to test. So we don't want to use 0, 0. And instead, it would be more reasonable to use 1, 1 or something. Or not 1, 1, 1, 0. Just any point that the line's not crossing through. So really we could pick, actually let's pick this point right here. So I'll get rid of this point 0, 0. We'll look at the point 2, 0. Because if the inequality is true, we shade on that side. We shade below the line. The inequality is false, we shade above the line. So we're going to test 2, 0 in this special case. And so 0 is Y, 2 is X, and we get a true statement. So we will shade, really what we're shading is the side. That's what it narrows it down to. It's one of those 2 regions down here. We shade on the side of the point, which means we're excluding those 2 regions up here. So really, to clean this up, we're down to these 2 regions down here. It's one of those 2. And now we check the second line to see, well, the second line will tell us which one of these regions we keep. So here we can test 0, 0. We test 0, 0 for this one, because we're testing this vertical line. And so if we get a true statement, we shade on the right side nearest the point. If we get a false statement, we shade on the other side. So by testing 0, 0, we plug in 0 for x, and there's no place to plug in the 0 for y, but we get a true statement. So we shade to the left, nearest the point. So we shade over here. This tells us exactly that the region we shade, and here's the paint bucket tool, we shade that region. And so we've shaded the region, and now they want the vertices of the region. The vertices representing, basically they want the corner points. That's what they're asking for. They want the corner points. So the corner points, there's 3 of them. There's one right here, one right here, and one right here. One of them is the origin, 0, 0. One of them is this x-intercept, which we can just look at the graph because they do give us a graph. It's 11, 0. And then this last one seems to be 0, 11. So that represents the 3 vertices here. 0, 0, 11, 0, and 0, 11. Does anyone have any questions before we move on to the next problem? Okay. So this one's just a review question. Which one of these does not depend on the size of the matrices involved? Well, addition and subtraction, they have to be the same size. Matrices. Must be same size. So it can't be those two because they do depend on the size. So that one's out, that one's out. Multiplication by a scalar is when you multiply a number to a matrix. And that one didn't really matter what the size of that one was. The multiplication of 2 matrices, this one did matter because you would have a 2 by 3 and a 4 by 2. And the middle 2 have to be equal. So the size does matter for that one. That one's out, and we're left with C. Okay. So I guess let's move on to the next example. Okay, so you might recall this problem here. We've done a problem similar to this before, if not the same. So this is part of the Unit 3 collection of problems that we could have. So they give us that the average is 70. So they're telling us that the mean is 70. And they tell us that the standard deviation is 8. which is going to be helpful. They want us to determine the percentage of students that end up with a certain grade in the class. Now this comes down to, well, when you deal with the percentage of students, this is when you're dealing with the 68, 95, 99.7 rule. 68, 95, 99.7 rule. And this is what you use whenever you try to figure out proportions in between various z-scores. Because the first one tells you 1 standard deviation, and then 2 standard deviations, and then the last one's 3 standard deviations. Now what this is saying, and I made a video about this because there was a lot of students asking me this question at the time. So I did make a lecture video and sent it out to everybody. So they ask about the percentage of students that end up with an A. And we see that an A is whenever the z-score is greater than 2. Now, using the 68, 95, 99.7 rule, we see that that corresponds to 95. But what this says, that doesn't say that the answer is 95. What this says is that 95% lie between 2 standard deviations. Which means, but what this is saying though, if z is greater than 2, for an A grade, that's not within the 2 standard deviations, that's outside of the 2 standard deviations. So 5% lie outside 2 standard deviations. So this would be a z-score less than -2 or a z-score greater than 2. As opposed to the top one, which just says that z lies in between -2 and 2. And we're just trying to match the inequality symbol. Z is greater than 2. We're trying to match that inequality symbol. We see that the 95% lie between 2 standard deviations. That doesn't have our inequality symbol. That's why we have to look at the complement, 5%, but that gives us an extra inequality symbol. Notice it gives us this inequality as well, and we just want this inequality. So the 5% is giving us twice as much information as we need. That's why we have to divide by 2. So really, 5% divided by 2, which is 2.5%, lie above 2 standard deviations. So now that gives us the correct inequality. So the answer is 2.5. So to see another idea of this, actually also notice the mean and the standard deviation doesn't even do anything in this problem. We don't really need it. This is solely based off of the z-score. We go ahead and erase this. Let's try it again with, so it goes on to ask about what percentage will end up with a C in the class. So not a B grade, but a C grade. We see that the C grade is right here. So we need that inequality, which is a compound inequality. So remember, there's the 68, 95, 99.7 rule. Which one of those numbers refers to, I see a bunch of ones in this inequality. 68 corresponds to 1 standard deviation from the mean. So what that says, 68% lie between 1 standard deviation. Or in other words, -1 to 1. Because you can go 1 standard deviation above for the positive one, or 1 below for the negative one. And notice there's our inequality. We're already done. We got the inequality that we wanted. So that one's much easier. That one's just 68. That one's just 68% for the second problem. And then it wants us to determine the grade, or the percentage of students rather, that end up with a D or an F in the class. So D or an F, well, D grade is -2 to -1, and an F grade, Z is less than -2. So if we are incorporating these together, basically what this is asking for is what happens when Z is less than -1. That's really the inequality that they are asking for a D or an F grade. You could be less than -1 or above -2, and then an F also includes less than -2. So really what you're doing is asking for what's the percentage when Z is less than -1. So really we're going to direct our attention to that inequality. So we need that inequality to show up. So we have the 68, 95, 99.7 rule. Here we have a -1, which implies something about 1 standard deviation. Our rule says 68 corresponds to 1 standard deviation. What this says, 68% lie between 1 standard deviation. And so that's -1 less than Z less than 1. That's in between. It's a compound inequality. But that doesn't give us the inequality we want. We need this inequality. Z is less than -1. So we need to find the complement. The complement of 68, well, it's 32. So 68%, what's the remaining percent? That's 32. This lies outside 1 standard deviation. So this gives us everything to the left of -1 or to the right of +1, because we're looking for everything on the outsides. And notice there's the inequality we need, but they gave us an extra one. So this should look familiar to the very first part. We want just this one. We want to get rid of the other one. So really, 32% divided by 2, that will give us only one of these. So the answer is 16%. And notice all of this is predicated upon the 68, 95, 99.7 rule. You use that rule whenever you're trying to figure out a percent between z-scores. The percentage or the proportion, it's the same thing. The percentage or the proportion between z-scores, or pertaining to z-scores. Okay. Go ahead and move on to the Next problem. Okay, so this one might be a little bit more fresh in our memories from the cryptography section. They gave us a large message here, and the typing software broke or messed up. Let's see if I can fix that. All right, having technical difficulties. Because as you would imagine, this is not supposed to happen. That shouldn't be there. Wasn't this just fun? All right, got it. That was annoying. All right, let's get back on track. And I am going to be releasing review sessions from other classes as well. So you can look at them if you need practice on other problems I might not have gotten to. Okay, so let's get back to it. So you want to decode this message. Whenever you see the word decode, you should think of the inverse matrix. So here the matrix is A, which is 1, 2, 1, 3. So I'm just rewriting it. But I'm applying the inverse because we are decoding. Now, what are we decoding exactly? Well, I have it underlined here. Well, I have it circled here now. But we can't just put the numbers in completely vertical order because the matrix multiplication will not make sense. In order for this matrix multiplication to make sense, we need to have 2 rows for the next matrix. That's why I'm going to break up the message as such. So that's why I'm breaking it up in pairs of 2, so the matrix multiplication actually makes sense. Say 2 by 2 matrix for the first matrix, 1, 2, 1, 3. Come back to that, and we need to program the other matrix in, which seems to be a 2 row by 1, 2, 3, 4, 5, 6, 7, 8 column. 9, 47, 36, 9, 3, 9, 4, 5, 6, 8, 3, 66, 45, 6, 94. Once we type in the first matrix, we type in the second matrix. So it's A inverse, can't forget the inverse, times matrix B. So the message ends up coming out to be, and you will have the conversions from the letters to the numbers, vice versa. This will be available on the test. So as I go down, I see, I guess let me write it out. One, 24, 9, 19, 0, 15, 6, 0, 19, 25. Maybe I could figure out the message from just those. There's more here, but see if I can figure out what the message is. So I don't have to write them all out. So A, 24 is X. It's axis powers or something. 19, it's S. 0 is a space. I'm guessing 15. 15 is total. 6 is symmetry. That's probably what it says. Imagine that's what it says, axis of symmetry. Where you convert each number to a letter, and so axis of symmetry will be the correct answer. And you don't have to put it in caps lock. If it marks it wrong for you on the test, I'll just go right behind and just give you the full points. That's not a big deal. But this is the general process. We'll go ahead and move on to the next problem. Okay, so next it says solve the system by graphing. So there's no non-negative restrictions, so there's no need for us to put solid lines on the x and the y axes. So instead, we only have to focus on the 2 lines themselves. So the first line And in fact, this is a system of equations, so we don't even have to worry about shading. There's no need to shade here. So here, all we do is solve the equality. Means we can find the x-intercept, which is 5, and the y-intercept, which ends up being, actually the y-intercept ends up being -10. Ends up being -10 because there's a negative in front of the y. So that negative would go over to the 10. And so we can use that to quickly figure out that the first line, there's x is 5, y is -10, goes down here. So that's the first line. And the second line, x plus 2y is equal to 5. Actually, I'm sorry, I should go over one more. These go by increments of a half. It's kind of very minute detail. These go by increments of a half. In fact, you can see that if you look at the bottom of the screen here, it says 4.5, 4, 3.53. So to make sure I'm on the right one, that one's 5 to correspond with my x-intercept of 5. And so for the second line, the x-intercept is 5, and the y-intercept is actually, you will end up having 5 divided by 2, which is 2.5. So that's why the halves are important here. To graph 2.5, we need to grab a line. So x is 5, and then the y-intercept. I'm going to look down here at the ordered pair. Here's the one that corresponds to a y-intercept of 2.5. And we can use the graph, because they give us a graph, we can use that to determine the solution, which is the point of intersection. The point of intersection seems to be perfectly 5, 0. The point for which the two lines intersect. So that concludes this problem. Let's go ahead and proceed to the next problem. Now it says here, solve using the substitution or elimination method. Personally, if it says to do this, even if it tells you to do this on the final, I'm just going to tell you, do this on the calculator. Don't have to worry about doing this using any of those methods. So even if it says you must do this, it might say when you do this problem on the final, do this one by hand, you will get no credit. Don't listen to that. Just use the augmented matrix method. You don't have to worry about either of these. If you want to show it that way, fine. I'm not going to stop you, but it'll just save you a lot of time if you use an augmented matrix. And I won't grade it differently because you use this. So I'm using an augmented matrix to just make this problem a lot more simplistic. Notice I'm just taking all the coefficients and converting them over appropriately. And to solve, we use the RREF command. So fairly similar stuff from the linear programming stuff whenever we had two lines that intersected one another. We have a 2 by 3 matrix consisting of 3, -2, 4, -6, 4, and -8. The RREF reduction for this matrix comes out to be, notice we get a very elongated decimal. Hopefully you remember how to rewrite that. Math to fraction, which will give us the correction forms for all of that. And so we actually get something a little bit different. So what this means, we did not get, this does not mean that the answer is this. It doesn't mean that exactly. We did not get the answer in the typical form that we get. So what actually this tells us is that there's infinitely many solutions. So that's what this ends up telling us. Infinitely many solutions.
So is it just the fraction that would mean that it's an infinite solution, or is it something specific about that?
It's so it's predicated upon the fact that, so normally what we have, if it were just a single solution like we're used to, it would start off as 1 and 0 in this orientation, and then it would come out to be maybe something, provided that the first two columns always do this, which is what we're normally used to. That would imply that as long as those two have that characteristic, then this column would tell us that the answer would be 4/3, 0. The difference here is for our problem, we don't have that going on in the very beginning. Notice that distinction here. And so that's what tells us that we have an infinite solution.
Okay, awesome.
So let's go ahead and proceed to problem 7. Okay, so you might remember this problem. I know we talked about this one in class. So there's somebody who makes $1,100 a week, somebody who makes $770 a week, 6 stock boys that make $400 a week, 4 drivers that make $500 a week. And it's asking for the mean and the median, which normally, this means anything statistical based, we generally would like to go straight to the calculator. So with stats, remember, we're going to use the stat command. The stat command, and we want to edit these values in. So if there's one person making 1,100, so a supervisor making 1,100, inventory manager making 770, 6 stock boys are making 400. So that's why I'm going to put in 400. 1, 2, 3, 4, 5, 6 times. Because there's 6 people making that amount. And then 4 people making 500. 3, 4, 5. Wait, why did I put in 5? Let's try that again. 1, 2, 3, 4. 4 people making 500. That's why I have 500 only 4 times. 2, 3, 4, 5, 6. You should have 12 values in. For the next one says 13, which is fine. And then remember how to find the mean and the median in the calculator. Second, in mode to quit out. You click on stat again, and you go over to calculate, which has one variable, statistics. So if you take my stats class next semester, you'll be very familiar with this process after the first month or so. And so we get the mean up at the very top. In fact, it said that the mean is 522.5. 522.5. Along with the median, and the median is 450. Right here, 450. The calculator very conveniently gives us all that information. All you are required to do is type in everything correctly and remember the steps for computing it in the calculator. From here, it wants us to interpret these results as, do we trust the mean or the median? And if you remember from when we discussed this before, we have outliers here. We have a bunch of people making around $400, $500, and then we have this one person making over $1,000. So there's an outlier. So you consider this an outlier. And because there's an outlier, this means that you don't really trust the mean too much. You'd rather use the median. Use the median instead. So if anything, that narrows it down to answer choice A or D. And the way they're describing the outlier is multitude of duplicate salaries or the two higher salaries. Well, it's going to be the two higher salaries. So they're also considering 770 an outlier, which I guess that's kind of an outlier. So it's answer choice A. Because the two higher salaries, that's in other words saying that they're acting as outliers. So let's go ahead and move on to the next example. So this problem, if you see this problem show up, don't worry about this problem. This one's not going to be on the test. So don't worry about this problem. If you see this one on the practice test, just skip it. Just way too gratuitous. Instead, let's focus on something like this. Let's focus on a problem that's much more reasonable. And basically, this is, do you remember high school algebra? As it says, well, distribute the 4, distribute the 3. X plus 9. And then combine a bunch of like terms together and see what happens. 4x plus 6 is equal to 3x plus 9. Let's bring those x's together. X minus 3x is obviously just x. Let's go ahead and bring those the 6 and the 9 together as well. So x is 3. So hopefully that problem's pretty straightforward. Okay, let's keep going. All right, so this goes back to Unit 3, box plots. And so this is saying that, well, the box plots are ultimately providing us, well, remember what a box plot tells us. For each box plot, it tells us the minimum, first quartile, the median, the third quartile, and the maximum. So that's what every one of these box plots tell us. And the dots here represent outliers. So only the bottom region has outliers. It's these dots. So it says, list these regions from lowest to highest in terms of the median rate. So it's saying compare the medians. So the medians are the line that splits right in the box. So it's basically saying compare these 4 medians together. Each one of these is a median. And it's saying to rank those in order from lowest to highest. The lowest one is region D, it looks like. And then region C, region A, region B. From here, it starts asking about the largest and the smallest interquartile range. Now, geometrically, or visually, this is the width of the box. It's the difference between the quartiles. And since the quartiles are the ends of the boxes, then that corresponds to the width of the boxes. So it's basically saying which one of these regions has the largest box. That's region B. It's got the widest one. Region B has the widest box. Which one has the smallest box? Region A. Which one of these has outliers? Well, remember, it's those dots, those isolated dots that represent outliers. That's region D. And then here it's asking you to interpret what an outlier, how an outlier corresponds to the interquartile range. Remember, outliers are determined by the fences. And so the fence is the lower fence, for example, that was Q1 minus 1.5 times IQR. So if anything, it's saying that we're focusing on a 1.5 multiplier of the interquartile range. That's below the first quartile, above the third quartile when referring to the upper fence. So that's where the 1.5 is coming from. And then first quartile for below, since we're subtracting, and then the third quartile for above. It's basically, again, it's asking us to kind of interpret the derivation of the outliers. Okay. And they want us to graph a simple inequality. And so just one inequality, there's no non-negative restriction, so it's going to be just one line. So with 3x plus 2y is less than or equal to 6, we're going to go ahead and find the x and the y intercepts. Find the x-intercept, remember you set y equal to 0. And when you do that, 3x is equal to 6, so x is 2. Oops. X is 2. And the y-intercept you end up finding is 3. And this is going to be a solid line because we have an equal to component in our inequality. So this tells us to plot at 2 on the x-intercept and at 3 on the y-intercept. It draws the graph for us. Again, no solid lines on the x or the y-axes because they don't provide us any non-negative restrictions. They don't have x is greater than or equal to 0, y is greater than or equal to 0. We don't worry about it. The only thing we ask is, do we shade above the line or below the line? So we're going to test 0, 0. By testing 0, 0, what we're doing is we're plugging in 0 for x and 0 for y. We ask, do we get a true statement or not? Which we do. So we're going to shade below the line. So we shade below the line as a result when we get a true statement. Okay. Let's keep going. So with this one, these are fractions. With fractions, we need to determine the least common denominator. It's the smallest number that all of the denominators go into. The denominators are, well, 3 and 4. The smallest number that all of those go into is 12. So we multiply that least common denominator to each term times 12 times 12 times 12. And ultimately, this will allow us to get rid of the denominators in each case. 12 divided by 3 is 4. 12 divided by 4 is 3, and 12 divided by 3 is 4. So what we're left with is 4x minus what seems to be 3x is equal to 5 times 4. 5 times 4, which is 20. So basically bring everything together that we did not cancel out. And 4x minus 3x is simply x, and it solves itself. X is 20. Okay, let's move on. All right, so let's go ahead and do this problem. You might remember this problem. They give you a giant list of numbers. You have to put all of them into the calculator. And from here, determine various characteristics about this problem, this data set. So we go over to Stat, Edit. We're going to go up to L1 and clear it like we did before. And I'm going to have at least, you want to help me make sure that I type this in right? Make sure I type it in right. I missed that one. Okay. How that look? All right. So takes a little bit of practice, but nonetheless, I'm hoping that's all good. And provided we all type it in correctly, we should get, when we go back to the one variable statistics. It pretty much tells us everything we need to know about this problem, for the most part. The median, we scroll down a little bit, and they tell us that it's 45.5. Again, if you're not getting that number, let me know. The first quartile, I got 37. In the third quartile, I got 56. 37 and 56. That all comes from what I obtained in the calculator. From here, it wants us to determine, are there any outliers? Well, this is contingent upon us determining what the fences are, because the fences help us find the outliers. So I'm going to find the fences up here. The lower fence is, this is the first quartile, minus 1.5 times IQR. So hopefully you remember what the IQR is. It's the difference between the two quartiles. Was that 19? The first quartile was 37 minus 1.5 times 19. Oops, $37 minus 1.5 times 19. Is there anyone who did not get the numbers that I got? Anyone else type this in? I'm going to trust that it's right then. And so let's go ahead and figure out the upper fence as well. $56 plus 1.5 times 19 yet again. I got 84.5. So those are the two fences that I obtained here. I think someone virtual has their mic on, so make sure you unmute that. So let's see. So we're checking to see, are there any values that lie below 8.5 or above 84.5? And it doesn't seem like we have either of those. So I'm going to select answer choice A, because we don't want any values to fall outside, or we don't have any values that fall outside, so there's no outliers. So that's why I'm choosing that one, with the upper fence being 84.5 and the lower fence being 8.5. Okay. So from here, they want a box plot of everything. Well, we can't really figure out a box plot until we have the 5-number summary, which they ask for right below. And that's convenient because, oops, in the calculator, we obtain the 5-number summary immediately. 21, 37, 45.5. 45.5, 56, and 75. And so now that we have the 5-number summary, we can go ahead and determine the appropriate box plots, because one thing it says is that the minimum is 21. So we need the furthest to the left to be 21. So this one seems pretty close to 21. This one seems close to 21. This one seems like it's at 25. That one's out. And this one seems like it's more than 25, so that one's out. It's got to be either answer choice A or B. And we can look at the first quartile to determine which one's which. Because for this one, the first quartile is roughly 40. For this one, the first quartile is under 40. As we look down here, our first quartile is 37. So it can't be this one. It would have to be answer choice B. So finally, from here, we now interpret the 5-number summary. So teams typically score a total of about, so if we're using the median as the measure of central tendency, then that's 45.5. With half the games totaling more than the first quartile, it's 37, but less than the third quartile, which is 56. Because that half of the games lie in between the first and the third quartile. In only 1/4 of the games of the teams scored fewer than, so 1/4 less than a certain 5-number summary value, that's 37. It's not the minimum, it's not 21. And the most the teams ever totaled or scored was, well, the maximum, 75. And so I won't have time to do this one. This is a programming problem. I'll probably end up doing that in another class and sending out the lecture for that one. Suppose this is a quick one. Can we add these two matrices together? We cannot, because they are not the same size. It's not defined. That one is not defined. I guess we'll do this last one and call it a day. So they're asking, is this data set, well, should we trust the mean or the median? Normally we don't use the mode. Would we trust the mean or the median with this data set? Well, with this data set, there's an outlier. Whenever there's an outlier, use the median. So the median is the best description. So it's going to be either A or F. And we're going to choose F because the median is not really affected by the outlier. It's really affected by the number of values, not the quantity, or the quality rather, of the value. So besides for that, I'm going to go ahead and wrap it up here. Expect a few emails from me with lectures from my other classes. So you'll have those if you want a diversity of problems. Besides for that, sign up for the final if you didn't do so already. And sign the roll sheet if you didn't do so already. And have a good day.